question number 7 is very much liked by physics professors because of its ratios and proportionality. So it says, an astronaut wants to measure the acceleration of gravity on planet X. So let's go ahead and make a chart that says gravity on planet X. And we know that's what we're looking for. It says, on Earth, her powerful dart gun will shoot a dart a maximum horizontal distance of 30 meters before the dart returns to the same height from which it was shot. So we know on Earth, acceleration due to gravity is 9.8 meters per second squared. And it says that you go a maximum horizontal distance of 30 meters when this dart is shot like a projectile. So this is a maximum of 30 meters. And it says, however, when you go on planet X, she performs the same experiment and finds that the dart gun shoots at a maximum distance of 45 meters. And the question wants you to find out what the gravity is on planet X. So, before we think of any physics, I think of this from a logical perspective. If the dart gun is shot on planet X, and it can go farther than it can on Earth, that must mean gravity is reduced. If you think about walking on the moon, you see people jumping really far. Instead of taking one step, they go 10 feet in the air. So we know gravity is lower on the moon than on Earth. So if the dart is shot further, then gravity is lower on planet X than it is on Earth. So right away we can look at our answer choices before we do any math and say, okay, answer choice number 5, 15.9 meters per second squared. That's way more than Earth has gravity. So we can get rid of answer choice 5. Same reasoning behind answer choice number 4. 12.4 meters per second squared is much larger than Earth's 9.8 meters per second squared. And we can also get rid of answer choice 3, which is 9.8 meters per second squared, because we know if it went farther on planet X, then it can't have the same gravity as Earth does. So now we're down to choice 1 and 2. So the easiest way to do this question is just to set up a proportion. And what I did is I went ahead and I said 9.8 meters per second squared times 30 meters is equal to 45 meters times x, where x ends up being your gravity for planet X. So if we type 9.8 times 30 equals 294, and then we go ahead and divide it by 45 meters. We get 6.5 meters per second squared, which is answer choice number 1 for question 7. So question number 1, we just set it up as a ratio and said 6.5 meters per second squared, which is less gravity than Earth, which makes sense why the dart would go further.